Now it does ask for graphing form. By the way, the 4 points of intersection on that last problem are where the two graphs cross. They cross in 4 different locations, the parabola with the circle. So over here, we can get stuff from this. Even though it's not graphing form, I can still see I've got intercepts, x-intercepts. I got an x-intercept at -3, and I got an x-intercept at 1. So +1 and -1, 2, 3. And since A is positive, I've got a parabola that's going to be doing one of these little things. Okay? Here's something that you can do. If you look for the middle, the average of the two x-intercepts, if I add -3 and 1, -3 plus 1 divided by 2, that gives me the midpoint of these. -2 divided by 2 is -1. So that means at -1, I'm going to have a vertex. That vertex is -1 comma something. If I plug that -1 into the equation, I get a -1 plus 3, which is 2, and a -1 minus 1, which is -2. What's 2 times -2? -4. That's my vertex. So if I know that that's my vertex, and I know my A value is 1, I can write in graphing form without even foiling, completing the square, nothing. I got an x plus 1 quantity squared based on that, -4. So that's graphing form, and we went about it a different way, but there are different ways of doing things. If I complete the square here, it's already in that form. What am I going to add to both sides? Adding 1. Adding 1. Okay? Complete the square. That 4 is going to get moved over to that side. This becomes y equals, that factors to be x plus 1 quantity squared. That 4 goes over here. It's a -4. Trick question, how many solutions? Many solutions. Yeah, there's an infinite number of solutions there because the equation's the same, just in a different form.